All right, my name is Emma Abreu, and this is my presentation on our solar system. I got this image here from the NASA website, and I love it because of the pretty colors, and it shows the planets in order, so that's nice, very educational. Okay, and on this slide here, I have our current solar system configuration that I got from our last project. And I like that it included, all of our planets and a little extra. I didn't know that I knew all the planets orbit the sun, but I didn't know that they all did so very individually, that they're all in their own space. They're all in their own space in time. On this slide for my astronomy history, I have the two scientists who came up with our solar system models. So we have Claudius Ptolemy. He was a Greek astrologist, astronomer, mathematician, and geographer. Was born in 8100, and he proposed the geocentric model, which explained that Earth was at the center of the universe, and all the planets and asteroids revolved around Earth. And that was what was taken until the early 1400s, when Nicholas Copernicus proposed the heliocentric model. Copernicus was also an astronomer and mathematician, and his heliocentric model would propose that the sun is at the center of the Earth. And obviously, we now take that for fact, and it is the same model that we use today. On this slide here, I discuss a little bit of the distance that the solar system is. And so the solar system is measured with astronomical units, and each astronomical unit is 93 million miles long. And there's 122 of those that make up the length of our solar system. And on this slide here, I have a little joke between the moon and the Earth, and it is 238,900 miles apart, which is obviously such a very small fraction of, the 93 million times 122 miles length that the solar system is. On this page here, we have an image of the diameter of the planets. So there's 8 planets that make up our solar system. The first 4 closest to the sun in order are Mercury, Venus, Earth, and Mars. And these four planets are our rocky solid planets, and they're considered that because of their surface textures. And there are smaller planets. The last 4 are the gaseous planets: Jupiter, Saturn, Uranus, and Neptune. And these are larger because when the sun was being made, the leftover particles that flew out further into the universe, and they preferred the colder temperatures that you get with being farther away from the sun. The larger planets and these light gases of helium and hydrogen clung to these planets and had them grow. That's why Jupiter has 139,822 kilometer diameter as the solar system's largest planet, compared to Mercury's 4,878 kilometer diameter as the smallest planet in the solar system. Okay, here I have Europa, and Europa is one of Jupiter's moons. It is one of the most likely contenders to support life. It is got an icy water outer shell, and then within that there is water, a salty water ocean, and then an iron core and mantle. And it is the most similar to Earth, which is why it's most likely to support life. And I think that that's really interesting because it's not even a planet; it's a moon of a planet. And I think that it's quite the coincidence that it has very similar conditions to Earth, and how unique and special it must be to be the only planet that supports life in all 8 of them. So that's special. And then I have my references. And thank you for coming to my presentation.